Hello, you're welcome once again. In today's lesson, we're going to be looking at balanced and unbalanced forces. In other words, we shall be looking at the resultant of forces. Now, remember that force is a vector quantity. So what we have resultant of forces can as well be taken as a resultant of vector quantities in general. For example, the resultant force, resultant weight, resultant magnetic force, resultant acceleration, resultant velocity, all of those can be replaced by one word called vectors, resultant vectors. Now, by the end of this lesson, I expect that each one of us must be able to describe what balanced forces are, what are unbalanced forces, and then to define what a resultant force is or a resultant vector, and finally calculate the resultant of different forces acting on a body. Those are the objectives of our lesson today. So to begin with, we're having this picture here, and it is a tug of war. My question to you is, which side is going to win? Of course, we know that in the tug of war, two sides are pulling towards one side. So these are pulling towards this other side, and this one's also pulling towards the other side. So the winning side must be able to pull the other side towards itself. Now my question is, which side is going to win? Okay, yes. At the moment, we can't tell because we don't know who is stronger. We don't know which side is stronger. But assuming that no one wins, it means that this side is having an equal force as this other side. For example, 20 newtons and 20 newtons. If the forces are equal, then we talk of the word balanced. If one is bigger than the other, for example, if this side is pulling with a force of 120 newtons and the other is pulling with the force of 20 newtons, then these two forces are not equal, and therefore the winner will be taking this other side. Okay, so how about this side here? Whom do you think is going to win? Because someone may say that this one is older than these ones combined, so this one must be stronger than this other side. So that is one alternative. Another one will say that these ones are very many, and therefore they'll be pulling this other old person towards themselves. That is also another version. But since we don't have the figures, since we don't know who is stronger than the other, we cannot judge. But if the two are pulling with equal forces, if the two sides are pulling with equal forces, then those ones are balanced, like we've said. If one is stronger than the other, then those are unbalanced forces. Likewise, if we are pushing in different directions, for example, this one is pushing this way, this one is pushing this way, this one is pushing the other side. So we don't know who is stronger. And a very good example is here. One side is having a force of 500 newtons combined. In other words, when you have this person, this one, this one, this one, this one, all of them pulling towards this other side, their total force is 500 newtons to the left. And then all of these ones are pulling with a force of 450 newtons to the right. Now, if these ones are not equal, like we're saying here, that 500 newtons is bigger than the 450 newtons, then these two forces are unbalanced, they are unequal, and therefore the winning side will be towards the left-hand side. So the difference between these two forces is what we call the resultant of forces. What we observe when we have balanced forces, and what we observe when we have unbalanced forces acting on a body. Just write down one answer on each of those 2 points there. Okay, so effects of balanced and unbalanced forces. One, when the balanced forces are exerted or are acting on a stationary body is the one which is at rest. So when they're acting on a stationary body, the body does not move. That is what we need to know. If one side is pulling the other side and the other side is being pulled by unequal force and the body was at rest, then the body does not move. If balanced forces are exerted on a moving body, the speed will remain unchanged. For example, if the body was moving at 20 meters per second, the speed will remain as 20 meters per second. because the balance forces are being acted onto that body there. So, in other words, two things we need to observe here are these: that if the body is at rest, then the body remains at rest. If the body was moving, then it will be moving with the same speed. It will neither accelerate nor decelerate. That is, it will neither speed up nor speed down. So those are the effects of balance forces on bodies, one stationary, one moving. Then, when unbalanced forces are acted upon a moving body, then either the body will speed up, in other words, it will move quickly, or we say that it will accelerate, or it will decelerate, depending on the direction of the resultant force. So that is what you observe when forces are acting on a body. Let's first discuss this briefly. What do you think will be the effect on motion of an object when the resultant force is 0 newtons? We have discussed this. Pause the video and read down something about this. What answers do you think are possible here? Okay, so if the resultant force is 0, then the object's velocity stays the same if the body was moving. And if the body was at rest, it will remain at rest. So you have two effects there. In other words, if the body is moving, it moves with the same velocity. If the body was at rest, it will be having 0 velocity. It will be at rest as well. If the resultant force is in the direction the body or the object is moving, for example, in case someone is riding a bicycle and then you simply push, what will be the effect on the body? Yes, the object will accelerate. In other words, the body will speed up. The velocity will increase. All the speed will increase. All those are simply different ways explaining the same answer. Then, number 3, what do you think would be the effect on the motion of the body if the resultant force is in the opposite direction in which the object is moving? Yes, I hope that you've got this one right and that this object will decelerate. All the speed will be going down, it will be reducing. That is very good.